Today, I'll be talking about Riemann's hypothesis, which is considered one of the most challenging concepts in math. How can you send a message on Instagram and no one except the intended recipient sees it? Answer is encryption. You need to agree between the sender and receiver to unlock the message. Encryption methods / algorithms use sophisticated methods to hide the data. Only with the correct key you can read the message. Hey, I was just reading about prime numbers like 5, 7, and 11. Did you know that prime numbers are used in encryption methods that can help save Instagram and Facebook? Instagram and Facebook rely on prime numbers because they don't have a specific formula or pattern. Lots of people have studied prime numbers before and their properties. For example, how many prime numbers are there? What is the gap between prime numbers? But until today, no one has reached a proof claim about prime numbers and their properties. A powerful function used to study prime numbers is a zeta function. Remember when you were in grade 5 or 6 and your teacher told you to graph fx equals 2 to the power x? This is a function. It is a relationship that includes more than one or just one term. Zeta function is defined for real values. You plug in a real number and you get zeta of that number. You can see the equation of the zeta function right now, and now you can see the graph of the zeta function. 1836. Riemann studied zeta function with complex numbers. It turns out that there is a strong relation between zeta numbers, complex numbers, and properties of primes. We can't square any number and get a negative value, so mathematicians invented imaginary numbers. I equals square root of -1. A complex number is a number having a real part plus an imaginary part. It can be written as a plus b times I. A and b are real numbers. My claim is about the zeros, or more specifically, the non-trivial zeros of the zeta function when we work on complex numbers. My claim says that all non-trivial zeros of the zeta function have the form of 0.5 plus b times I for any value of b.
Riemann has found many zeros that satisfy his proof, but until today no one has proved or disproved his theory. The first 10 to the power 13 zeros. But until now, no one has either proved or disproved his hypothesis. Now you're thinking, what will we gain if we solve Riemann's hypothesis? We will be able to count prime numbers, determine prime numbers property,